First we see how the light refracts through a thick glass block. Suppose this is a thick glass block. This is the thickness of the glass block. It is made up of glass, a transparent material. This is the incident ray. This is the imaginary normal. This is the refracted ray. And this is the normal, and this is the emergent ray. Now, this angle is angle of incidence I, this angle is angle of emergence E. This angle can be considered as R1, this is R1, or say R. This R is the angle of refraction in the second medium, which is also equal to angle of incidence over here. So, we are considering A, B, C, D as the glass block of thickness T. Let PQ is the incident ray, QR is the refracted ray, and RS is the emergent ray. In the plain glass slab, the surface AB and CD are parallel to each other. You have to remember, if the two refracting surfaces are parallel to each other, in that case the incident ray and emergent rays are also parallel to each other. If we produce the emergent ray backward, then this perpendicular distance is called lateral shift. This perpendicular distance is called lateral shift or lateral displacement. It can be seen if the two refracting surfaces are parallel to each other, then the incident ray and emergent ray, both of these two rays will be parallel to each other, and the perpendicular distance between this incident and emergent ray is known as lateral shift or lateral displacement. Now let us see what are the different factors on which this lateral shift depend. First factor on which the lateral shift depend is thickness of the glass slab. Thickness of the glass slab. And how it depends on the thickness of the glass slab. Thickness of the glass slab means this line CD will go down or the line AB will go up. When the CD line will be going down, means the thickness increases, then the refracted ray inside this glass slab get more space to travel, and in that case the value of lateral shift will increase. So with thickness, how it is related? It is directly proportional to the thickness. It is directly proportional to the thickness of the glass slab. Larger the thickness, more will be the lateral shift for any given angle of incidence. For example, if you measure the lateral shift for this glass slab with angle of incidence 30 degree, and you take another glass slab with the same angle of incidence 30 degree, if the thickness of the glass slab is double, you will find that the lateral shift also increases. Second factor is it depends on angle of incidence. How it depends on angle of incidence? Lateral shift depends on angle of incidence. How it depends on angle of incidence? More the angle of incidence, more is the lateral shift. Means when I equal to 30 degree I1 and I2 equal to say 60 degree, if this lateral shift is x1, this lateral shift is x2, then x2 is greater than x1. So you can say higher the angle of incidence for a constant thickness of the glass slab, more will be the lateral shift. So it can be seen, it is directly proportional. It is also directly proportional. So lateral shift depends on thickness of the glass slab. Higher the thickness, more will be the lateral shift. Lateral shift depends on angle of incidence. More the angle of incidence, more is the lateral shift. And it also depends on the refractive index. It also depends on refractive index of the material of the transparent medium. How it depends on refractive index of the material of transparent medium? Mu, it is denoted by mu. So higher the refractive index, if the refractive index of the medium is more, the lateral displacement will be more. Since the refractive index increases with the decrease in wavelength of light, so the lateral displacement increases with the decrease in wavelength of light. So it can be seen that lateral displacement is more for violet light and lateral displacement is less for red light. Suppose this is a thick plane mirror. This is a thick plane mirror and this is the silvered surface. The concept of multiple image we are going to discuss. Image. Suppose this is one incident ray. On this surface there will be a partial refraction and reflection. Again at this surface, at this point, there will be total reflection. Again at this point there will be partial refraction and reflection. At this point again reflection. It goes on this way. Now this refracted ray produces first image. This ray produces second image. This ray produces third image. Suppose this is image I1, this is image I2, this is image I3. So this way, infinite number of images can be received on the screen. But here very important point must be noted that this is the brightest image. The second image is the brightest image. Why the second image is the brightest image? The reason is, out of all the image, the light suffering a strong first reflection at the silvered surface only for this particular light ray. That's why the second image is the brightest image.